I'll try to make this model. And on like when we will be working on this model, we will explore a few things which are important when you work with Grasshopper. And like one of them is very useful graph mapper element. Then we will talk a little bit about geometry math, and we will start looking at data trees. It's the most fundamental and most complex data element in Grasshopper. So far, we talked about data items and lists, and data tree is a kind of generalization of lists, and that's actually how all data in Grasshopper is presented. So we will start talking about data trees. Okay, and as the first exercise, I would like to ask you to create this like quite a simple um, uh, diagram in Grasshopper, which will create a set of circles, like the same radius circles, all with center on the axis z parallel to xy plane with equal spacing. So it doesn't matter how many circles, just more than one. So, and what I ask you to do, just open your Rhino, open your Grasshopper, and try to create a scheme which will produce a stack of circles like that. I'm going to use z vector just to create several vectors and to move the to specify the location in the z direction where to create the circle. And basically she created circles and moved them just and applied probably, is it one circle, Shangdan?
Yeah.
Yeah, it's one circle, but there are several z movement vectors which are creating circles and for each of these vectors this circle is being moved as many times as specified. And now what we are gonna do, we want to make, you see, our form is more complex. So it's based on circles, but they're all having, like, all forms have different radiuses, right? So in your solutions, so if you think about modifying your solutions to make not this form, like we will talk about how to create this form later, but to make circles, to make circles with different radiuses. It can be a linear like logic, like multiply by 2, each next circle is multiplied by 2 in radius. Can you modify your schemes just to make the circles to make them like to make sure that they're changing radius each next one? How you like in your diagram, you just you multiplied one particular circle, right? So, and if you just multiply it, then you won't be able to vary their radius, right? So you need to it just like your final element probably won't work. So you need to do it somehow a little bit differently. So you see, you have your planes, right? So you created, you use this unit vector and you generate as yeah, you use unit vector once, right, to create and it gives you a movement, right? So, and you use a circle to create a circle. So now you want to create several circles, right? So then you will need to create several vectors, right? And then you will need to create several radiuses. So you see, it's, and they should be all driven by one number because it's like how many you need, right? So let's put circle by the end because circle is will be the final outcome, right? Okay, good. And obviously radius is something which we will create. We want to specify. Okay, so and your numbers, okay, and what, how we can approach that here? Yeah, I think the element you are missing here is range. Try to type range here. Okay, click it. You see what this element does? It splits a domain of numbers into steps. So a domain is a range of numbers, say from 0 to 100, whatever you specify, from 50 to something, right? And then you specify number of steps, and the outcome will be the domain. Like now, the default domain is from 0 to 1. Right. If you hover over domain, you will see that the default domain is from 0 to 1, right? And now we need to specify number of steps, how we split it. So you can connect a number slider to the steps. Like you have one, right? Just drag it, connect, yeah, and then hover over range. You will see what it will give you, right? It gives you 11 values, right? So from 0 to 1, 11, right? So potentially it can generate, it can be a base, for example, for your radius. Like you already have 11 numbers and they are all different. That's all we asked for, right? So you can use it as radiuses, right? Just connect the output to the radius, right? And you already have like different radiuses. Now you need to somehow to use this 10 number to generate 11 vectors, right? So mhm, mhm, yeah. So and you I remember Shagnon did it somehow. You can also use a data range, I think, but what else can? So you have 10, right? You can use a data range also here, actually. For example, if you use a data range, right? Oh, it's just range. Yeah, range. Yeah, it's yeah. And then just use a number slider to specify the domain, like make the domain different. Like yeah, yeah, yes. So it will be the domain, and if you hover over domain now, you will see that this domain from 0 to 4. So you didn't specify the bottom range of the domain. So it's 0 by default, and 4 is your top number. Now you need to split it, and you can use the same number slider which you used for the radiuses to split this domain into different radiuses. Yeah, just connect this number slider to the steps also. No, not this one. Yes, this one. Yeah, yeah. Yes. And now you have, first of all, you can just, yeah. Now the problem is, now you see, if you hover over range here, you will see that different numbers were generated, right? And also 11 numbers, right? And basically, we want to use them as z vectors. So basically, you need now to use these numbers as factors for z unit, right? And then you can use it as plane locations. Yeah, and now try to use it as planes for the circle. Okay, it worked. And now if you want, yeah, and now you can play, you can change the height, you can change the limits, and you can play with your model. Okay, Shagnan, are you ready to go ahead?
Yes.
Yeah, okay, good. So now I will show you a very nice way which the creator of the model, I should show you his name just because I used his sample model and I want you to know his name. So it's Edwin Hernandez. So he wrote an article, Grasshopper Data Trees Explained. And he's an expert who works at shapedriver.com. You can check this site out. Um, and he created this model. He used this model to explain some things about data trees. We won't talk exactly about what he talked in his article. And I want to show you how I modified his scheme a bit, but basically how he did it, it's very close to what we have done with Erin. But a little bit different. And then he used one very useful element in his model. So I will quickly recreate his model. Just a moment. So we have a number of profiles. So height is for data range for heights. Then also we need a range for radiuses. Oh no, so it's here, it goes here. So domain is from 0 to 1. Then here we want, yes, we want the vector. Yeah, right. Yes, yes. Okay. And then finally, we will create circles as you did. All right. So it should work like that. Okay. So now it comes to the point when we would like to create radiuses. So if we connect straight, what we will have here, yeah, they're just very small because radiuses are so small, right? So, okay, so I will, first of all, I will use a remap item to make the values, to scale them up. So, okay, so this element takes values, and then we can source domain is from 0 to 1, and then our target, I think it should be like that. Just a moment. So I want to make it like
Leo, where did you
yes,
find the remap component?
I just typed. Oh, there is a very fine key combination. Control Alt, and then you click on the element, and it shows where the element is. You see?
Okay.
Control
Yeah.
Alt click. It's yeah, very useful.
Only remap numbers comes up when I type it in. Is that,
Oh,
it's a different thing, isn't it?
remap numbers. I think it should be yes. Remap numbers. Yes, exactly. This is what you need. Yeah. Okay, and then yes, yes, these are radiuses. Okay, okay, if we scroll down, radiuses 0, 9, 18, 27. Okay, so now we have our scaled, just a moment, our scaled circles. So, and we can scale up. So what this element does, it takes numbers and then we specify how we scale them, basically, right? Why we did that? So we could perfectly redefine the domain, right? And here in the range element, and then we would get bigger numbers. But what we would like to use, we would like to use graph mapper element. So let's type graph, is it? No, how it's called? Just a moment. Yeah, graph mapper. Yeah. And we feed our initial data in this element. So, and what this element, what this element is, we can specify graph type, and we will use Bezier graph for now. And what we can do, we can change the graph using the same method as we usually use to edit Bezier curves. All right. Okay. So we're doing that. Let's see how it works. Yeah. And then let's change the number of profiles. I will increase it. And you see how I'm changing my graph and how it changes the profile of our vertical uh, vertical uh, profiles. Okay. Okay. And actually, you can specify different graph types. And this element will allow you to map data. So how it works, just I want to show you how it works. So it is shown on this slide. Just a moment. So basically, input values, they are on the axis X, right? And as we created it, we divided domain from 0 to 1. So the input domain from 0 to 1, just to have like fixed domain, right? And basically in our scheme, it's just split it in particular number of like in particular number of say equally spaced numbers, right? And what this thing does, so basically it takes it maps X value to Y value using the graph. And the output is for each X input, it gives Y output, right? So this way, just mathematically, we can very elegantly create quite sophisticated shapes. Okay, let me try to reproduce the shape which was there. Right? Was it like that? No, it was different. Okay, so let's. I like his shape more, but it's okay. So this is called graph mapper. So you can see how you can use it, and potentially with this wide range of different graph types, uh, just you can remap numbers really easily. And as we know that the output domain is from 0 to 1, we just need to scale it up to map it to the range we would like it to be. Okay, is this more or less clear? Yeah, I hope so. Okay, uh, just ask if you have any questions. Just ask uh, further. Now what we want to split our circles, because in the future, because we want to create these breaks, and to split the circles we use shutter element. Shutter, yeah, like that. So, and shutter elements takes our curves and all our um, circles are curves, and then it takes where to split. And basically where to split is given in lengths. So here, for example, we can, like, if there is any default, there is no default. Okay, so we can assign particular numbers. Say if we set it to multiple numbers, can be, no, doesn't. Okay, so it can be 0, and I don't know, 0, 1.5, and 3. Commit. Zoom is getting in the way. Okay, commit changes. So, and then we can see that each curve has been split in 3 segments, like according to the output. You see, like n equal to 3, it means that each element of the list has actually 3 sub-elements. So they are splitted curves. But we still not have clear idea how it was split, right? Like and how we can actually visualize it. How we can actually visualize it. For example, we can take, so we always want to have some visual feedback. When we are building a Grasshopper model, it's always useful to have visual feedback just to control how what's going on, right? So let's see if we can find something useful. For example, endpoints. So if we connect here, and now we see our endpoints of our curves, and you see how close they are. Because actually length of each circle is different, right? And the length is quite high. We took 3 numbers just out of the blue, right? And it's obvious that these numbers are not what we want. We want equally space these subdivisions. So what we can do, first of all, there is just a moment. There is a very useful parameter in like input mode, I would say, in this element, and this mode called reparameterize. Let's see what will happen if we choose it. So where is it? Oh, they all disappeared actually. Just a moment. I need to change them a little bit to demonstrate. Sorry for that. So let's make them all less than 1, because basically what this reparameterization is doing, it is like 4 0.8 commit changes. Yeah. So what reparameterization is doing to the curve, it basically makes the length of the curve for this element will be always 1. So it doesn't matter what the actual length is. The length, like it takes length of each curve as 1, and when we split it, it will split it like in proportionally. So yes, this curve is bigger than 1, right? Then the actual numbers which we supplied, which will be scaled up just to split this curve according to like proportionally, like up to its real length. So for example, now if we supply 0 and 0.5, we will have 2 division points on different ends of the curve. All right. So, and it is exactly what we want. Basically, we want to divide them equally in similar proportions. Okay. So this transformation of input parameters is called reparameterized. Okay, now we want to split. For example, we want to split the circles in different numbers, not just like now we are supplying the numbers, right? So we do not want to supply the numbers. We want to specify, to parameterize the number of subdivisions, right? So we want them, we want to be able to generate 2 subdivisions, 3 subdivisions, whatever, right? So now my question to you, what element would you suggest to use for that?
Yeah.
Yes.
I think I lost the part why the circles were divided into 2.
Okay. Okay. That's okay. Thank you, Shangnan. Okay. So we supplied the curve to the shatter element, right? The curves all were different lengths, right? Each curve had individual length, right? So for example, let's take another a little, like let's take a simpler model. Let's put a circle on the board, and let's create this circle. It will be just a moment. So in the top view, we create a circle, and we supply it to this shutter element, right? So we have this circle. If we want to calculate the length of the circle, can we calculate it? Length. Yeah. So the length of the circle is 105, right? So, for example, for this shutter element, we want to what particular values we want to use to shutter this circle. For example, we will use 0 and 10 commit changes. Okay, so 0, it's the first point where the circle was shattered, right? 10, it is the length after that in another breakage point was inserted, right? So that's how this parameter, how the t parameter works. So if I add here, say 30, right? It is, this segment is 20 units long. Okay, so is it clear so far?
Yeah.
Yeah, okay. Now, why it doesn't work for us? It doesn't work for us because all circles have different length. All circles have different length. We can hardly specify all division points individually for each circle. It will be very inconvenient. So what we do, for this input, we are saying that this circle length is reparameterized. What it means? It means that despite this circle remains the same circle, this element thinks about it as about a circle with length 1. So for this shutter element, and just for this shutter element, this circle has length 1. So basically, it's somehow like, think about it, that it was scaled down to be of length 1, but inside this shutter element. And when it goes out, it's scaled up just to for it to remain the same. Just think about this that way. So at the input, it's scaled down, and then the shutter element deals with the same circle, but like scaled down to the length 1. Then we need to supply points where this circle is broken in the range from 0 to 1. So points 0 to and 1 will be at equal location, right? Because the whole length is 1, right? So, and we can provide points in between 0 0.1, 0 0.3 commit changes. And you see, actually, this is what was 10 units. And now it is 0.1 unit. This was 20 unit. Now it's 0.2 units. Because we are now, this circle is processed in 0 to 1 range. Is it clear?
Yeah.
Okay, so but you see the output is still normal, so it's scaled up back. Just this element doesn't modify the circle itself, it just breaks it. So, and it is a very convenient, and it's very convenient for us, like this reparameterization, very convenient, because now we can specify our division in a known, like in a known range of values, right? So now okay, and now we can come back to my question. So how would we supply values to split this circle in several equal segments and to make this number of segments a parameter? What element would we use?
Adding series?
Series?
No.
A series, it's actually it's a good suggestion, just it's a little bit we can try using series. Why not? Series. So series will take start value, right? And then it will take mm, what it's next? Step size and count, right? Yeah. Start value, step size, and count. I think it's perfectly possible to do what we want. Just okay. Just Shagnon, will you? Uh, if you can work on that, you can try to use it in your local model and try to create it this way. You will need to use some math elements because you will need to calculate the step size. And if you use count, or if you use a step size, you will need to calculate the count, and then you will be fine. So you can please try to do that. So any other suggestions?
Is it divide?
Divide what uh, divide, mathematical divide?
Divide curve.
Oh, divide curve. Divide curve. No, here you see this input takes numbers. It doesn't take points. So this input takes numbers and then it divides the curve according to the numbers, according to the length. Right? So you need to supply here a list of numbers. Like you see what we did. We supplied actually like particular numbers, and then it split um, the curve according to the numbers, like taking them as lengths along the curve. Is it clear, Erin?
Yeah.
Okay. That's why I'm afraid that divide curve won't work because we do not need points. We need uh, we need like range, like set of numbers. Okay, Ilsa, any suggestions?
No, not really.
Okay,
um,
okay.
if it's no points, then
It's just numbers.
yeah.
And we used an element like that already.
Uh, could you put in another? No, I'm not. No, I'm not sure.
Okay, okay, that's fine. Okay, Shangnan, are you ready with your solution?
No.
No. Okay, work on your solution. It can work. So I would suggest to use range element for that. And like try, like Ilse and Erin, try to put a range element and to supply a list of equally spaced numbers between 0 to 1 domain to t to the t input. Okay, can you try that? But basically that range, like range element works perfectly here. And you can see that now I can specify number of steps. And visually, I see that everything is okay. But if I actually, okay, and then so I'm still using my circle, which I used as an example. Now I will delete it because we do not need it and supply actual circles. Okay. Oh, sorry. Perspective view. Yeah. And so now we can play with it. Yeah, we can. So all circles are equally um, like broken in subsections. Actually, if we look at it, like if we hover over, because it's always in programming or in Grasshopper, it's always better to double check and to control what's going on. So in this element, data range, if we hover over export, we will like output, we will see that actually for our 4 points, it creates 5 values from and values at the start, at the end, they're 0 and 1. But for for circles of length 1, these points are at the same location, actually. So basically, we have one extra input. We provide one extra value for t. We would like to get rid of it. So we want number of values here to be we want to split exactly in 4, like with 4 different values. So we need to reduce this list because it's obviously a list of values, right? So we want to reduce it. Let's see what we can do. So where we have lists under set. And under set, we have shift list element, and shift list element takes a list, and then we can shift the list, shifting values in some direction, and we probably want to shift it towards the beginning of the list, eliminating 0, right? And let's see what it will do. Oh, and you see it put it not only shift it, by default it wraps the list. So 1 went to the first position, from the end went to the first position. We do not want it, and this parameter actually regulates this logic. So we put wrapping to false, and then you see 1 didn't go anywhere. 1 just disappeared. We shifted the list, and the last item just disappeared. This is exactly what we wanted. Now we have 0, 0.25, 0.5, 0. So we shifting this list to -1. We just got rid of this last element. Let's see how it will, like we can see it here if we use this panel. So we can see how it works. Let's see how if we shift differently. For example, if we shift 0, then it doesn't affect the list at all, right? If we shift it to 1, commit changes, 0 disappeared. So it was shifted up and 0 element disappeared. And it's our choice. We can continue with a list from 0 to 0.5 or from 0.25 to 1. It's both will work. So if we, for example, shift 2 elements, like 2 elements will disappear, right? So let's continue with -1 because I prefer to deal with 0 rather than with 1. So that, and then output of this element we feed here. Now this input has exactly 4 points where we want to break the curves. And the only, so and now what we are gonna do next? How we will shatter this element, and how we will how we will create these gaps. Like if we look here, we see that actually they were circles, right? And then somehow this breakage, they were broken. All circles individually were broken. This one, circles were broken in 3 equal curves, right? So how these sections were created? So I would think about we can make it 3 to make it look similar. So I would say that if we have a vector which connects endpoints of each curve, and we move this curve in the direction of this vector to some specified distance, and we do it for each subcurve, like this subcurve will go in this direction, in the direction of the vector specified by its endpoints. This subcurve to the direction specified by its endpoints, and this subcurve in the direction specified by its endpoints. Then it is probably what we want to do. Then these segments will be disconnected, and the only thing which we will need to do, we will need to create lines to connect ends of moved segments, and then we will be basically done with this model, right? So we already working on this model for an hour and a little bit longer. So I would say let's stop here. I hope you have time, if you are not too busy. If you have time during the week, try to create, try to figure out how you can create elements to move these subcurves in the direction you would like them to be moved, right? So and we can start with that next time and look at your ideas, and then we will finish the model, and based on the model we will be able to discuss data trees, which is a very important subject for Grasshopper.